Welcome back to part 5 of our live training session here with our 2004 Honda Civic Si. In this training module, we're going to be jumping into doing our full throttle tuning here on low cam or non-VTEC operation. We're going to learn how to set up fuel, spark timing, variable cam control, as well as the knock control. We have a lot of things to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our K24 swapped EP3 Honda Civic. Now in this training module, we're going to jump right in and start to dial in our full throttle operation on our low cam or non-VTEC. This is going to be something that you have to do in order to move on to high cam. So we need to obviously dial in idle first, then we dial part throttle in, then we do our low cam wide open throttle, then we can move into high cam turning on VTEC and going through that mapping. Now in this tutorial, we're going to be taking a look at how to dial our fuel in using our closed loop correction, how to dial our spark timing in using our knock control, and then also how to dial our variable cam control in. Now let's go over a few things of where we're at here. We'll go on to our mainline chassis dyno that we're going to be using for this tutorial and set up a few things on screen there. And then we're going to do our very first pull and start to dissect this and go through the process of dialing in wide open throttle. It's actually extremely simple, but you have to go through very specific steps and procedure when you're doing this on a K-Series engine. Let's jump in here and take a look. So where we left off in our last tutorials, we've dialed in our VE table 1 here. So we have our VE table 1 representing our low cam, VE table 2 here representing our high cam. We're having them activate or switch over when VTEC activates. So it switches between table 1 here to table 2 on VTEC. So in this case, we've disabled VTEC. We set it at 9,000. So we're focused just on our low cam, and we're specifically going to be focused on our rows right here. So row -4 up to about 2 psi. Now this is naturally aspirated. We're not going to see anything higher than 0 psi, but I scaled it so if we got a ram air effect as we're driving down the road and it did see some positive manifold pressure, it would be able to account for that in the scaling as we're finding here. Now we don't know if these values are accurate or not, so we need to go and dial them in. Now here is a catch here that we have to go in and keep in mind when we're working with our K-Series engine. Right now we've set up our variable cam timing so it's zeroed out at our high load area here. If we jump into our variable cam table, we're finding above -4. So -2 to +2 psi, so our rows right here. We've zeroed this out. We're going to be baselining everything with 0 degree VTC commanded. Then we're going to walk up our VTC going from 0, 10, 20, 30, 40, maybe 50. I have a 50 degree VTC gear on my K24 engine here. Now, the thing to keep in mind is as we start to move our variable cam, we're going to find that our fueling demand changes. So if we're making more torque, we're moving more airflow into the engine, and therefore we need more fuel. So as we're mapping our variable cam, our fueling demand, our fueling will need to be changed and updated. What we're going to do here, because we have the closed loop feedback and we can watch what's going on and it'll correct any kind of deviations or discrepancies from our fueling. So if it's off 5%, it'll correct it 5% under full throttle. What we're going to do here is dial everything on 0 degree. Then we're going to go in and we're going to go ahead and start to bump up that variable cam timing here in the table. Look at the subsequent changes in power output here in the chassis dyno, and then we'll review what that closed loop compensation is doing. One trick with the K-Series is if you don't have a chassis dyno available and you're trying to figure out mapping your variable cam timing, what you can do is every time you're moving your variable cam timing up another 5-10 degrees, look for what the closed loop compensation is doing running in closed loop. If it's adding some fuel as you made your variable cam change, that means that you're gaining power compared to the previous cam angle. If the closed loop compensation is taking fuel away, that means that you're losing torque, losing airflow, and you're losing power as a result. So you can keep an eye of what's going on with that closed loop compensation. We'll be mimicking that here on the dyno. Obviously we have the dyno to see the before and after, but we'll be looking at that during the calibration process, looking at the closed loop compensation. So what I'm going to do, dial everything in here with 0 degree VTC, walk the variable cam timing up. We'll keep an eye on closed loop compensation. Once we find the optimized variable cam timing, then we'll go into our V table and we'll do our final touch up, getting our closed loop compensation as close to 0 as possible. Now in conjunction with this, once we've dialed the variable cam in, once we've dialed in the VE table, get that sorted out, we can also then take a look at our spark tuning. Now our spark timing here from -3 up to 2 psi, we've set this at very conservative levels for a naturally aspirated engine. And in fact, this is probably going to be, I'd have to say at least 10 to 12 degrees less of spark timing than where we need to be at. Now we're doing this very specifically. One, we're making sure that we don't put the engine into a dangerous condition, having too much spark timing, getting into knock as we're doing our full throttle tuning and trying to get our air and fuel model worked out. The second part of this is going to be we keep the timing low so that we know there's no knock or preignition, which allows us then to go into our knock page here and establish our knock noise floor. So when there's no knock, we'll look at the knock sensor output and then we'll set our floor accordingly. So if we overstep that threshold as we're bumping our timing in, then we can know and see if we have actual knock. Pretty straightforward. We'll look at this process as we go along. Very first thing we're going to do, fire up the engine, go ahead and do our pool, and then evaluate the baseline of where we're at and trying to get that everything sorted out here. Now, one thing I want to mention, if we take a look at our coolant temp, we're about 167, 168 degrees coolant temp. I did have the engine running a few minutes ago, so everything is warmed up here, so we should be ready to go to start doing our pools. We don't want to make pools on a cold engine, so we always want to verify that the coolant temperature is at least 140, 150 degrees. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.